students, in this part we are going to use all the concepts that we have studied in earlier parts and use them in solving the previous year IIT JEE questions. Hello students, so today we'll deal with the questions that have been asked in the previous IIT JEE, and we'll see how the concepts that we have learned in the class will be using those same to solve the questions. Let's start. Now this is the first question that was asked in IIT JEE. The question reads, the two beams of light having intensities I and 4I, they interfere to produce a fringe pattern on a screen. Okay. Now the phase difference between the beams is pi by 2 at point A and pi at point B. Then the difference between the resultant intensities at A and B is, now it is given that intensity of the first is I, intensity of the second beam it is 4I. Now these two are interfering, they produce a fringe pattern on a screen. Now the phase difference is pi by 2 at point A. So if you consider, suppose point A, at point A, here the phase difference phi is pi by 2, and it is given that at point B phase difference phi is pi. Okay. Now what is the formula for intensity? Now we know that the formula for the intensity I is the net intensity I, this is I1 plus I2 plus twice of root over I1 root over I2 into cos phi, where phi is the phase difference between the two waves. So now if we try to put the values here for finding the intensity at A, what we have is I1 is I, I2 is 4I. So this will give you I, it is A, I1 plus I2 plus 2 times root over I1 into root over I2 into cos pi by 2. Okay. Now if we solve this, you know that cos pi by 2 is 0. Now if this is 0, that means this whole term goes to 0. What you have is 5I. Okay. So this is your I1, IA, the intensity at A due to the two fringes. Now we'll try to find out the intensity at B. This will be I plus 4I. We are using the same formula, plus 2. A is this, B is 4I, this, cos of pi. Now what is cos pi? Now we know that the value of the cos pi is minus 1. So put the values. This is I plus 4I is 5I plus 2 times root I into root over 4I will give us 2 times root I. So it is 2 times I, root I into root I. Cos pi is minus 1. So what we have here, this is 4I with a minus sign. So this is 5I minus 4I. What we have here is I. Now the question being asked to us is difference between the resultant intensities at A and B. So now A and B, so that is, it is being asked IA minus IB. What is the value? It is 5I minus I. So this is 4I. So this is answer. So if you look at the options, B is the correct option. Okay. So let's move to the next question. Now in a Young's double slit experiment, 12 fringes are observed to be formed in a certain segment of the screen when light of wavelength 600 nanometer is used. Now if the wavelength of light is changed to 400 nanometer, number of fringes observed in the same segment is given by. So okay, let's draw a screen here first. This is the origin. From here the light is being thrown. Sources are there like this. Suppose we consider this portion, this segment of the screen. Okay. Now this is the origin. It is given to you that in this YDSC, in this region 12 fringes are formed when you use a light of wavelength 600 nanometer. Okay. Now for 600 nanometer, what will be the fringe width? Beta. Now we know the formula is lambda d by d. So this will be lambda is 600 nanometer into capital D by small d. Okay, now since it is given that in this segment, suppose I give this length is x, in this segment there are 12 fringes. So that means what is x is 12 times 600 nanometer into capital D by small d. Okay, now what it says further is, if the wavelength of light is changed to 400 nanometer, the number of fringes will be given by, what is the number of fringes? Now suppose when the wavelength is this, what is the fringe width? Beta dash, this will be lambda times capital D by small d. Now I assume that there are n fringes in the same segment, in the same length x. This light will form n fringes, so that means n beta dash is equal to x, because we are considering the same segment again. This is equal to 12 into 600 nanometer into d by t. Okay, now once we put the value of beta dash here, what we have is this, n will be equal to 12 into 600 by 400 nanometer, right? This d by d will cancel out with this, and you will have this, n will be this by 400, so this 400 nanometer will cause this, you will have this will cancel, sorry 6 is there, this will cancel this to make it 3, this is 6 into 3, that is 18. So what is the answer? The answer should be B. Okay, let's move to the next question. Now in a Young's double slit experiment, it's given to you is that two wavelengths of 500 nanometer and 700 nanometer were used. These two wavelengths were used. What is the minimum distance from the central maximum where their maximas coincide again? So let's draw a figure. Suppose this is the screen, this is central maxima, these are the sources. Okay, now the central maximas of both of the wavelengths will coincide, right? Because here the part difference is 0, both 500 nanometer and 700 nanometer, they will have the maxima here. After that what will happen, they will have different fringe width, right? Because we know that fringe width beta is lambda d by small d. Now if lambda is different, beta will be different, because d by d is same for a particular set of YTSE. So if lambda is different, beta is different. So what will happen is that the first maxima coincides, but the next and the further maximas, they won't coincide, because this beta is different. Means for one it will form at this position, for the another one it may form at this position, because this for one it will be beta, for another one it will be beta dash. So it's now different. So question being asked is at what order they will coincide again. So when they coincide again, what will happen? Suppose they coincide again here at any position. I assume that they coincide at this position. Now when they coincide here, what will happen? It's coinciding, both of the maximas of coinciding. Now what is the part difference? Suppose it coincides at d sine theta, at the angle theta it coincides, the maximas of both of the wavelengths coincide. So in that situation d sine theta will be n times lambda. This is the condition for maxima. So this is equal to, suppose n is for the first one, into lambda is 500 nanometer, and this will be same as, suppose it's the mth order for 700 nanometer, and these are equal, right? Because they are coinciding, the maximas are going to coincide. Okay, so if we equate these two, what we get is n by m is 7 by 5. So the minimum value of m is 5, integral value of m, right? Because otherwise the value of n won't be an integer. So the minimum value of m should be 5. Okay, Obviously, why I am saying minimum value is because later on also, once it coincides again at this value, again it will come out of sync, and then again it will coincide at some other point. So you have to find out when what is the minimum distance. So when the first time it happens that it again coincides, then it will again coincide later on, but we are bothered only about this portion. So the value of m is this. When it is this m, we can find out the value of theta here, right? Why? How? What is d sin theta? Now sin theta can be written as y by capital D, right? Why? Because we know, if we draw the figure, suppose if it coincides here, this angle is theta, this length is small y, this is d, this is capital D. So what is this theta? Now we know for a small angle theta, sin theta is equal to tan theta. So tan theta will be this y by capital T, that is p by b. So this is equal to 5 into 700 nanometer means 10 to the power minus 9, right? So what is y? This will be 5 into 700 into 10 to the power minus 9 into capital D by small d. Now it's given here that capital D by small d is 1000. So this is 5 into 700 into 10 to the power minus 9 into 10 to the power 3. This makes this 6. These 2 makes this 4. So you have 35 into 10 to the power minus 4 meter. What means it? What it means is 3.5 millimeter. So that means they are going to coincide after 3.5 mm. This height, when they will coincide again, this is 3.5 mm. So after 3.5 mm on the screen, they will coincide again. Okay. So let's move to the next question. Now in a Young's double slit experiment, it's given that the maximum intensity is I. Okay. So the maximum intensity is I. It's given to you. What is the angular position where the intensity becomes I by 4? Now if the maximum intensity is I, what is the intensity of each of the slits? Now we know that the intensity, if the intensity is I naught of one slit in YDSC, and of the both of the slits will be I naught because they are identical in Young's double slit experiment. So if one it is I naught, the net intensity is 4 I naught, right? Now this value is given to you as I. That means the intensity of one of the slits is I by 4. Okay. Now the question says when this intensity will be I by 4, at what angular position? Formula that we have for net intensity is I1 plus I2 plus twice of root over I1 I2 cos phi, right? So now if we write this, this is I by 4 plus I by 4 plus 2 times root over I by 4 into I by 4 into cos phi, and it is given that the net is I by 4, right? So let us solve this and find out the value of phi. So if you solve it, this will cancel out with this. So you have minus I by 4, 2 into I by 4 cos phi. So this 4 cancels with this, I cancels with this. So what we get is cos phi is minus half. That means what is the value of phi? This is actually 2 pi by 3. Okay. So this is the value. This is 2 pi by 3. Now if the value of phi is 2 pi by 3, in terms of lambda, what will be the part difference? It will be, if this is phase difference is 2 pi by 3, what will be the part difference in terms of lambda? In terms of lambda, how you can find out? If you have a phase difference of 2 pi, it is lambda. So if you have a phase difference of 2 pi by 3, what will be wavelength difference? It will be lambda by 3. That means the path difference is lambda by 3. So if the path difference is lambda by 3, that means d sin theta, which is equal to path difference given to you, is lambda by 3, right? So sine theta can be written as lambda by 3d. Now if sine theta is lambda by 3d, the question being asked is, okay, angular position, the theta. So theta will sine inverse lambda by 3d. So which of the answers? Oh, okay. So B is the correct answer. So we got this option. Let's move to the next question. Now there are two coherent point sources S1 and S2. They are separated by small distance d as shown. The fringes obtained on the screen will be. Question being asked here is, what is the pattern of the fringes? Now you have been given the options: straight lines, semicircles, concentric circles, points. What kind of fringes we can obtain? So let's try to find out. Suppose, consider at a point this, there is a maxima or minima or whatever at this point P. Okay. Now suppose if this is a maxima, then the path difference will be integral multiple of lambda, otherwise it will be non-integral multiple of lambda, or it could be any value of lambdas. Since we have to find out the pattern of the fringe, let's assume this distance as y. So S1p minus S2p is the path difference. Let's denote this by lambda. Now this lambda could be anything, right? When it is lambda, this delta could be anything. When it is integral multiple of lambda, you will have maximas, otherwise you will have minimas. That means if you find out this S1p is, we can write like S1p, this is y square plus capital D square minus y square plus d minus d whole square. This is a constant lambda, right? So we can write it like this. Delta plus this square, right? So what we get, if you square this, plus square of this term plus twice of delta into square of this term, right? Now if you see, what we will get here is, all of the things, if you see, they are constant apart from this y. So this will give you the dependence of y on this screen, means how the y is changing, means how the pattern will be changing on this screen, but it won't give you the pattern that is on the screen going into the plane or coming out of the plane. Now since these two are identical, now you can see here, see, all this is constant, all these are constant. So y square is equal to this d square also goes on this side, some constant, this whole value is a constant k minus d square, so another constant, suppose alpha, right? This is y square is alpha. Now similar thing will happen when you try to find out this on the x screen, and you can write that x square or z square, whatever axis you want to take, this will again be a constant. This distance will again be a constant, suppose beta. Okay, so now if you see, this is alpha and this is beta, we can see that the equation for the whole holistic equation, this will be a constant k, which is the equation of actually a circle. So we can say that it will form concentric circles. As y varies and x varies, it will form concentric circles on the screens like this. So if you take out this screen and put it here like this, the intensity patterns will be like this. We have concentric circles. I hope that you have understood whole of this portion that we have studied, we have covered in this chapter. We have dealt with the question. These are the questions that are being asked in the IIT JEE mains and advanced as well. So you can see how we can use all these concepts to solve the questions. I hope that you will benefit from this and you will be able to solve any of the question that comes in any of the competitive exams. So thank you everyone. Thank you guys.
Having gone through our video lectures and video solutions may have cleared most of your doubts. For any further doubts, you may visit our site www.askIITians.com. On the site, you will find a tab called Ask a Question. Click on that tab. Clicking on the tab will take you to the next page where you will find an icon Ask Experts. If you want to ask any questions, you can select the category of the questions. Like if you want to ask question from suppose wave motion, click on that option wave motion, paste your doubts here. If you want to attach some image of the question, you can attach the image also. Your question will be answered within 24 hours to 48 hours.
So we saw some of the previous year IIT JEE questions and we used the concept that we have studied in different parts while solving these questions. So let us summarize what we have studied in this topic. We dealt with the interference pattern, then we went with the diffraction and the polarization and all of the wave properties of the light. I hope you enjoyed this lecture. For more videos on physics, chemistry, mathematics and biology, stay tuned to Ask IITians. Thank you guys. Bye everyone.